Today we're going to look at this mathematical idea that's known as a function. So what is a function exactly? Well, the easiest way to think about it, at least from its most basic standpoint, is that a function is a relationship between two sets of data. So specifically we'll have an input set of data, and then the function will convert that input into some kind of output data. And of course in this algebra class we'll be doing a lot of work with expressions and numbers, so a lot of our input will be numbers and our output will be numbers. Our input will be some kind of expression, and our output will be some kind of expression as well. Now the key thing about a function though is that for every input that I put in, I can only get exactly one output. So if you want to think of it like this, the way that we kind of teach functions to kids is that we think of a function as kind of this machine. This machine, you can put in an input, for example, a number, and for every one input you put in, you're going to get exactly one output. So for example, if I put in a 1 into the machine, I'll have a function in here that's some kind of instructions. For example, maybe my function is take in x equals 1, and then the instructions say take that x value, square it, and add 1 to that. So if I do this, I put in x equals 1, and then my instructions tell me to square it and add 1. 1 squared is 1, and then 1 plus 1 is 2. So that means that my output from this machine is 2. So my input is 1. I have a function that is some set of instructions, and then I get this output of 2. And I can put in a different input and still get just one output. For example, I can take the same function, x squared plus 1. If I put an input of 2, for example, well, that means take the 2 and square it and then add 1. Well, in this case, I'll get an output of 5. Now notice you can have the same output come from different inputs. For example, if I put in a -2 into this function also, so -2 is my input now. It tells me to square -2, which again is +4. And when we add 4 to 1, we'll again get +5. This is okay. This is still a function because even though I got the same output, that doesn't matter for a function. You can get the same output for different inputs. What we want to make sure is that for every input, we have exactly one output. So I wouldn't want to be able to put in a -2 and get two values out of that for some reason. That would mean that this was not a function in this particular regard. So a more convenient way of writing this, instead of writing our machine every time, we have some notation for this. For example, the way we typically write this is f of x. So we would usually say this f of x, or the function of x. This essentially tells us that x is our input variable for a function. So for example, I might have a function like this. F of x is equal to 2x squared minus 1. This is my function. And with this notation, my input value becomes whatever I put right here. So for example, if I wanted to find out what is the function of 1, I would just write it like this, f of 1. That means that my input value is 1, and I need to take that, and every time I see an x in my function, I need to replace the x with a 1. So the function of 1 would just be 2 times 1 squared minus 1. So this is 2 times 1, which is 2, minus 1 is 1. So again, the input for this is 1, and it turns out that the output for this is also 1. I could keep doing this with as many inputs as I want. For example, the function of 4, for example, f of 4. This just tells me to go to my function, and every time I see an x, I'm going to replace that x with a 4. So 2 times 4 squared minus 1. In this case, this will be 2 times 16, so 32, minus 1 is 31. In this case, my input to my function was a 4, and my output of my function was a 31. So why is this important? Well, if you think about a graph, a lot of graphs are functions. For example, we looked at, I think we looked at this guy last week, f of x is equal to x squared plus 1. Or maybe a better way to write this if you're thinking of graphing is y is equal to x squared plus 1. A lot of times we can write f of x, but a lot of times in functions you'll just see it written as y. This is basically saying that y is a function of x, where x is the input and y is the output. Well, if you recall, this graph actually looks like this. We'll see, if this is 1, for example, then this y value would be 2. There's a point 1, 2 on this graph because whenever x is equal to 1, y is equal to 2. Also, whenever x is equal to negative 1, then y is equal to 2. So in this graph, the point on this graph that exists here is actually just an input and output of the function. Because if you take a function of 1 for this graph, you'll get 1 squared plus 1, which is equal to 2. So your input is a 1 and your output is a 2, which means that the point 1, 2 exists on this function. Likewise, if I took the f of 2, the function of 2, this would be 2 squared plus 1, which is equal to 5. So that means that on this graph, if I were plotting this, whenever x is equal to 2, this point up here should have a y value of 5. So the point 2, 5 should exist on that graph because the input for the function is 2 and the output for the function is 5. So that's really what the ordered pairs mean for our graphs. Now with a function, we don't just have to be able to put in numbers. We can put in whatever we want. So for example, if I define a function to be 2x minus 3. Well, certainly if I take the function of 0, then I just plug in x equals 0. So this would be 2 times 0 minus 3, which is just negative 3. So in this case, if I graph this, for example, on that graph, the point 0, negative 3 would be on the graph. But I could also put in things like expressions. For example, I could take the function of x plus h. Well, what does this mean? Well, it's not that complicated. It just means whatever is right here, this becomes the input value for your function. So you should replace the x with whatever is right here. So the function of x plus h, for example, will be 2 times, instead of x, we're going to replace x with whatever is in the parentheses. So this would be 2 times x plus h minus 3. Or if I do some distribution, 2 times x plus 2 times h minus 3. And we get a different expression. We'll see that this is something we use with functions a lot, is to create new expressions from some variables. And so in this case, we're not necessarily dealing with exact numbers yet. Likewise, I could take the same function and say, what is the function of z? Well, again, just replace the x with whatever is in the parentheses. So in this case, instead of 2x minus 3, I'll get 2z minus 3. And this expression becomes my output for my function. In this case, I don't get a number or an actual number quite yet. Let's look at something that wouldn't be a function. For example, something like this, y squared is equal to x plus 1. If I'm trying to say that this is a function of x, where x is the input and y is the output, this is not actually true. Well, why is that? Well, if I put in, for example, x equals 1, 1, that's telling me that y squared is equal to 1 plus 1, so y squared is equal to 2. Well, what y values can I square and get 2? Well, I could definitely square the square root of 2 and get 2. But I could also square negative square root of 2 and also get 2. So in fact, I end up getting 2 different y values that work for one input x value. In other words, for one x that I put in, I get 2 y values out. So this is actually not a function. Because we said with a function, for every y value you put in, you have to get exactly for every x value we put in, we have to get exactly one y value back out, if x is the input and y is the output. I'll show you another example. Something like y to the 4th is equal to x. This is also not a function if x is my input value. So I'll put an input, for example, of x equals 16. Okay? So that says which y values can I take to the 4th power and get 16? Well, you can definitely take 2 to the 4th power. That'll get you 16. But you could also take negative 2 to the 4th power. Negative 2 to the 4th is still positive 16. So in this case, I have one input, but I end up getting 2 outputs, which means this is not a function. So you can hopefully kind of see the difference here between which expressions are functions and which ones are not. As you do a lot of these, it becomes a little easier to kind of tell right off the bat whether or not they're going to be a function. Though we do have some tests for those. So let's get a little more vocabulary. If I'm talking about a function, I definitely have my set of input values. So these are things that I can put into the function. And then I do something with it, and then I end up with some kind of output value. Well, we have some better math terms for this. We're going to say that the set of all possible inputs, we have a word for this. We call this the domain of the function. And then the set of all possible outputs so all the possible numbers that we can get out by putting inputs in, we say this is the range of the function. And sometimes finding the domain or the range is pretty straightforward, but sometimes finding it can be a little difficult. So let's do some examples. So for example, let's start with a function like this. F of x is equal to 2x plus 2. I'd like to figure out what is the range and the domain of this function. So let's start with the domain. Remember, the domain is all the x values that I could put into this function. It's all the inputs that actually work with the function. So for example, I can definitely put in 1, because if I put in 1, I get an output value. I get an output value of 4 in this case. I can put in x equals 0 because I'll get an output value of 2. I can put in pretty much any number I can think of, right? And in fact, there's no bad x's that I can put into this that will make this function not work. If I put in negative numbers, it works fine, I'll get an output. If I put in positive numbers, that works fine, I'll also get an output. If I put in 0, that works fine, I get an output. If I put in fractions, that's fine, I'll still get an output. Even if I put in a number like this, the square root of 2, which is irrational, I'll still get an output of 2 times the square root of 2 plus 2, which is in fact a number, right? So that is an output, so that's okay. So it turns out for this function, the domain it's just all real numbers. In fact, there's no numbers that I cannot put into this function. Anything that I put in there will give me an output. So whenever we're looking for the domain of a function, we're looking for all the numbers that we can put in that basically don't break the function. That we can put in and the function still operates. So I'll give you an example of one that doesn't allow you to put any number in. So consider this function, 1 over x minus 3. So if I'm trying to figure out the domain of this function, I want to figure out all of the numbers that work in the function. And so sometimes a good way to do that is to think about, are there any numbers that won't work in the function? And for this one, there definitely is. If I put in an x equals 3 as an input, what happens when I try to get an output? Well, I'll plug x equals 3 in, so f of 3 will end up giving me 1 over 3 minus 3, which is 1 over 0, which we've already said we can't divide by 0 in this class. So this is actually an answer that's undefined. It doesn't make sense to us. So if we put in f of 3, we actually will not get an output for this particular function. But anything else will work. Any other number that we put in here will work. 3 is the only bad thing that could happen. In this case, the bad thing that could happen in this function is to divide by 0 because we have division. So in this kind of function, we're going to look for what x value makes this function be divisible by 0. Well, if x be equaling 3 makes the function not work. So for our domain, we'll just say it's all real numbers except x equals 3. So all the numbers work except for x equals 3. This is one way to write our answer. The other way I could have written my answer was simply just write x is not equal to 3. That would be a good way to write the domain, because that tells me that every other number works. Or if I wanted to write my parenthetical documentation, in my parenthetical notation, if you haven't been using this, it's fine. You can use this way, but some of you might have been using the parenthetical way of writing this, set notation. I could say it's all the way from negative infinity up to 3, not including 3, and then from 3 to infinity. So these are the 3 ways I could have written this. Most of the time you'll see people, this is typically the easier way to write something like this. Just write x not equal to 3, and that'll definitely get your point across. So let's look at another example. So a function like this, f of x is equal to 1 over 2x minus 3. And actually, we did a 1 on top of the other one, so let's do maybe a 3 up here. So the function is 3 over 2x minus 3, where x is the input value. So I'd like to find the domain of this function. Okay, so I'm going to start by asking myself, what are the bad things that can happen? Well, if I have division, really the only bad thing that can happen is that I will accidentally divide by 0. So that's what I don't want to happen. So what x value would make this denominator equal to 0? Well, if I set the denominator equal to 0, I just have an equation, and I can solve this equation. So I'll add 3 to both sides, and I'll get 2x is equal to 3. And so that tells me that if x is equal to 3 over 2, this denominator will be equal to 0. And in fact, you can check it in your head. 2 times 3 over 2 will be 3, because the 2's will cancel out. And then 3 minus 3 will be 0. You would get 3 over 0 in this case. So that tells me that x equals 3 halves is a bad input. I can't use that for this particular function. So in my domain, and in fact, that's the only bad input. Anything else, when you put it in, you'll get a number. It might be an ugly number, but you'll get something out of the function. So in this case, my domain is everything except for 3 halves. Everything else will work in the function. So I'll write that x is not equal to 3 halves for my domain. So typically, anytime you're dealing with division, you need to really worry about dividing by 0. And so this is the main thing we're going to look for. There's another type of function where we have to deal with square roots. And that's the other bad thing that can happen, is if we try to take a square root of a negative number. So for example, something like this, the function of x is equal to the square root of 2x minus 1. What is the domain of this particular function? Well, what is the bad thing that could happen? Well, there's no division, so we definitely can't divide by 0. So that's not going to cause us any problems. However, we know in math that we can, at least in what we've done so far, we can only take the square root of either 0 or positive numbers. We can't take the square root of negative numbers. So if I'm going to find my domain for this, whatever is underneath this square root better be at least 0. It should be 0 or greater. Well, I can solve that using an inequality. I could say, well, if this function is going to work, then the part that's underneath the square root better be greater than or equal to 0. Better be at least 0, otherwise the function falls apart. So then I can solve for this and figure out which x values make this true. Okay, so I can add 1 to both sides, and then I can divide by 2. Dividing by positive 2, so I don't have to change my sign. And I'll get that the x values at work are all the x values that are at least 1/2 or greater. So I'll say that my domain for this function is going to be all of the x values 1/2 or greater. Or if I wanted to write this using my interval notation, I could write it from 1/2 to positive infinity, including the 1/2. Now you can check this and see that this works. For example, if you pick something like x equals 0, which according to this is not in the domain, it shouldn't work in the function. Well, if I put in x equals 0 to this function, I'll get the square root of 2 times 0 minus 1, which is just the square root of negative 1, which, yeah, sure enough, that doesn't work for us because we can't deal with square roots of negative numbers quite yet. So 0 won't work. And in fact, anything, if you put in 1/2, you'll get 0 here, right? 2 times 1/2 is 1 minus is 1, then minus 1 is 0. Square root of 0, that's fine, no problems. But anything less than 1/2 we put in will give us a negative number. Anything bigger than 1/2 will give us a positive number to the square root. So you can check a few of those on your own if you don't quite believe me, but it definitely works like that. So these are the two main things I have to worry about when we're looking for domains. So if you want to kind of make a checklist, at least so far, we can add some things later, but right now we're just going to deal with dividing by 0 and taking the square root of a negative number. Okay. So these are the two things that we want to look for whenever we're trying to decide what is the domain of a particular function. So I can take actually both of these ideas and combine them into a larger function. So for example, a function like this okay, so the square root of x minus 5 divided by x plus 2. So I have to worry about two things. In this case, I do have division, so I do have to worry about dividing by 0. And I also have a square root, so I do have to worry about which x values are going to make me take the square root of a negative. Let's kick those out and not include them in the domain. So we need to solve this one in two parts if we're going to look at the domain. First of all, which x values make the denominator equal to 0? Well, we can always just take the denominator and set it equal to 0. X plus 2 is equal to 0. This one's pretty straightforward, but this is a method you can always use to solve it. Set the denominator equal to 0. See which x values make that happen. Well, that happens whenever x is equal to negative 2. So I know in my domain, I definitely do not want to include x equals -2 because that causes bad things to happen. What else don't I want to happen? Well, I definitely want whatever is under the square root sign to be 0 or greater. So that'll be my second part. I want to set the part under the radical, under the square root, x minus 5, needs to be at least 0. So x minus 5 needs to be greater than or equal to 0. So that tells me that x needs to be greater than or equal to 5. So that's the other part of my domain. Now, at this point, we need to look at our two instructions that we have here and kind of put them together into one thing. For example, this is saying that all the x values have to be greater than or equal to 5. This says none of the x values can be equal to -2. Well, if we say that x is greater than or equal to 5, that automatically assumes that we won't have a -2 in there because -2 is smaller than 5. So really, this is kind of redundant to have this here. So really, for my domain, the only thing I need to have is that x is greater than or equal to 5. Because if I have that, it's automatically going to mean that x is not equal to -2. So it's a little redundant. We can get by with just writing it as x is greater than or equal to 5. So whenever you have two parts of your domain that you're considering, at the very end you need to put them together and kind of logically figure out how you want to write your domain. I'll give you a different example. So something like this, f of x is equal to x minus 2, we'll put square root of x over x minus 2. Okay. Again, I have division and square root, so I have to worry about both division by 0 and taking the square root of a negative number. I'll worry about the division by 0 first. It doesn't matter which order you do them, but we'll just do that one first. So if I take the denominator of this and set it equal to 0, this would be a bad thing. So it would be really bad if x was equal to 2. So that means in my domain, I definitely don't want to let x equal to 2. So that's definitely going to be outside of my domain. What is the other thing? Well, the square root of x. So it would be bad if whatever's under here is a negative number. So whatever's whatever's inside the square root symbol, in this case it's just x, it better be greater than or equal to 0. So that's the other part of my domain. Well, I have to look here. I have to be careful. I'm saying that x is greater than or equal to 0, but x also cannot be equal to 2. So in this case, I do need both parts of this information because 2 is greater than or equal to 0. So if I didn't have this part, it would be saying that 2 is okay, but 2 is definitely not okay to have in this particular case. So if we wanted to really write this, I would write this using interval notation. It goes from 0 to 2, not including 2, but then 2 to positive infinity. Another way we could write this is it's saying that maybe x is greater than, so maybe x is in between 0 and 2, not including 2, so that needs to be strictly less than 2. Or x is greater than 2. This is a little bit better notation to write it in, but if you're not really familiar with it, maybe you don't want to use that. This for my class, if you write something like this is acceptable as well. I would understand what you meant. But there's a few ways that you can go through and write these domains. You basically want to write it the clearest way possible. You want to make it so it's not too difficult for someone who's reading your answer to know what you mean. Now it should be noted again that something like this, if you think about the domain for this function, 3x squared plus 2x minus 3, well, there's no division in it, so there's no harm, there's no chance of having division by 0. There's also no square roots in this, so you can't take the square root of a negative number. And in fact, any x value you pick, you can always square it, multiply it times 3, and then multiply it times 2, add them together, subtract 3. You'll never have a problem doing that. You'll always get some number. So in fact, the domain for this function, there's no bad x's. So maybe if you want to write that down, there's no bad x values, so that means that the domain is going to just be all real numbers, or all real x values. So it's possible that you won't have any problems with your domain. The more of these you'll do, the easier it'll start to become to spot the ones that are going to have problems with the domains and the ones that aren't going to have any problems and just have a domain of all real numbers.